This call is now being recorded.
शुरू कर अर्पण शुरू कर अर्पण शुरू कर
Hello. A very good morning to everyone. My respected sir and my delegates present over here. Today I am going to speak on the topic tomato leaf disease detection using a convolutional neural network with different transfer learning techniques. Next slide, please. So this presentation is done by myself, Orphan Banerjee, and my teammates অনুরাগ শীল, অনুজ শ, অদ্রিজা দাস, অভ্রাংশু চক্রবর্তী, সায়ন্তন দাস, স্বরূপ দেবনাথ, অর্ণব মুদি, আদিত্য কুমার and Abir Mukherjee under the guidance of our professor Anirban Bose. So in this presentation we are going to discuss about the detection of tomato leaf diseases by using CNN. Here are the contents, that is introduction, problem identification, motivation, dataset and source, data visualization, proposed methodology, transfer learning, result and discussion, and finally ending with conclusion. So we all know that agriculture is the backbone of Indian economy. The tomato crop is cultivated in all seasons and it is one of the most common vegetables cultivated in India due to its high nutritive value. Tomato leaf diseases poses a major threat to the overall production. The plants which are affected by the diseases account for 10% to 30% of the total crop loss. There are many kinds of tomato leaf diseases, such as you can see from the presentation, that is early blight, late blight, leaf mold, etc. So it is a major priority to identify these diseases in order to prohibit immediate spread of the disease affecting other plants and preventing any heavy losses in the yield. So in this project we have developed a model by using convolutional neural network, or known as CNN, to detect and identify the diseases from any tomato leaf image which we will take as input, and giving the prediction that it is what disease with a much higher efficiency than by doing it manually. So here we are seeing what is our main problem. The problem which we are facing, the problem identification, that is detection and identification of a tomato leaf disease. We will take an image of the tomato leaf as an input, and the model will predict that that it is suffering from which disease, or whether it is a healthy leaf or not, with an accuracy percentage that it is 98% accurate or 87% accurate, and we will develop a real-time application for the above mentioned problem. Next slide, please. So what is our motivation behind this project? Since farmers are unable to procure expensive protective system for their plants, so there is a strong motivation for introducing a system which can be quickly and easily trained to work and detect the problems. The main objective of this project is to present a model to use transfer learning technique to extract relevant feature related to the image of tomato leaves along with the CNN with alternate kernel function in order to detect and identify the diseases. Next slide, please. So here we can see the dataset and code. We have used the dataset which is available in the website Kaggle. We can access the dataset from by clicking on the hyperlink I have attached here, and here is the code which we have done on the Google Colab. The Colab notebook code is also attached here. We have used Inception v3, VGG16 and ResNet here. So clicking on each of these code will open the Python in collaborative notebook. So here we have trained almost 10,000 images, and here are the images of the type of each of the diseases that we have trained, that is bacterial spot, early blight, late blight, leaf mold, septoria leaf spot, two-spotted spider mites, target spot, mosaic virus, and yellow leaf. And also here is an image of a healthy tomato leaf. We have trained 10,000 images for our model. From this proposed methodology, my friend Anuj will continue.
Thank you, Arpan. So here we trained our CNN model with the data set that we can and that we take from Kaggle as told by my teammate, and we use and before training the model, we pre-processing the image data to generate the classification model. And as we as if we need to find the type of disease or the type of leaf, tomato leaf, just if we give the test image, then the image will be pre-processed, and then it will be applied to the classification model, and that will give us the actual type of the image. So here we can see this is a healthy image, healthy tomato image. So we get healthy as a final result. So that is the methodology. Moving to the next slide. This is the actually we build this model using the process of transfer learning. Transfer learning is the method of reusing a pre-trained model knowledge for another task. Transfer learning is already a created CNN model, and its small part is again trained with our data. And transfer learning having different techniques like Inception V3, ResNet, and VG16, and lots other. Here we use only Inception V3, ResNet, and VG16. And this is our result and discussion portion. So this is our hardware details that we collected from the Google Collaboratory. As my friend told that we use Google Collaboratory uh, to do our codings. So this is the specification of our GPUs. Moving to next slide. Uh, when we trained our model using the Inception V3 technique, then we get the accuracy. Then we get the variation of accuracy with epoch as this, and the variation of loss with epoch is this. And finally, we get the accuracy with Inception V3 after 5 epochs, 79.44%, and a loss of accuracy loss of 11.65%. When we do the same process using VGG16, we get the accuracy of 87.92% and the loss of 37.44%. As we can see, the loss here is comparatively more than the Inception V3. So we 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 move with the Inception V3 for creating our final implementation of application. And also when we trained our model using ResNet, we get the accuracy of near about 47.47%, which is less than both of others. So finally, this is the interface that we created uh, using using the Visual Studio Code, and the HDF file that we created from the uh, Google Collaboratory after training these models, after creating these models. And here, this is the local link to access the application. So let's see, does it open? Okay, it might take long time. So wait, let it open. So it may not working. Yes. So this is the final interface that we get after 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 some coding in Visual Studio and using the HDFI file. And here we can see a browse file option. When we click on the browse file option, we get a new tab to select the image. Excuse me. So here is the uh, validation image that we collected to validate our model or to showcase you the actual. Here, if we sorry, when we select the leaf mold leaf, it will upload it in this interface. It uploaded. Uh, then the image will occur here. So as we can see, we uploaded leaf mold image. So we expected to get the image as leaf mold, and here we trained like this that it will also print the accuracy with the confidence level or confidence percentage, that how much confident the our model is about its results. So it's loading. Yes. So here this is our leaf mold type leaf for tomato. Here when we click on the button predict, it will give us our desired result. Let's see, it's running here. We can see it's take a long time for us due to connectivity issue. It's running. So here, finally we get our result. Here, the message is published. The this image is most likely belonging to tomato leaf mold. As we are expected to give the leaf mold type, it is a leaf mold type of leaf uh, for of tomato, and here we are getting 100% confidence level. Means our model is 100% confident about its results. So that is it. So anytime we can in real time we can use this application. So moving to the conclusion. So here, so in this project, we actually proposed a tomato leaf disease detection using convolutional neural network with different transfer-learning techniques, we already told, Regnard inspection v3 and VG16, and we finally implemented our model using the inspection v3, as we get a good percentage of accuracy. It may be much more better, but actually here we get 39.42% with inspection v3, and then we implemented our application using the Visual Studio. In future we have planned to develop a real-time leaf disease detection for all type. Here actually we are interested for only tomato leaf, but in future we will try it for other leaves also. So thank you. Anurag, please stop the